Hello students, I am Ravi. I'll be teaching you theory of computation. So first of all, before addressing the theory of computation, let us understand how important this subject for GATE point of view. For GATE, from theory of computation, we can get good marks. Like most of the time I observed sometime some papers we got 10 marks, some paper we got 12 marks, some paper we got 8 marks. So average marks we can say we can expect from this subject will be so 10 or 11 or 12 marks. We can understand 10 marks, we can say average, you can say 10 marks we can get from theory of computation. And this is like it is new to you, like because if you see the theory of computation, the term may not be digested for you, correct or not? See, unlike other subject, if I talk about operating system or computer networks or DBMS, by listening, like by looking the term, we can understand this subject is talking about something, correct or not? Let's say computer networks, it is talking about what? So networking, like all computers are connected through wire or wireless, they are communication, correct or not? Communicating each other or sharing of data, sharing of resources will happen. When I'm talking about operating system, it is might be talking about like the design principles of operating system, how operating system will work. Right? It could be mobile operating system or desktop based or server based. But when it comes to theory of computation, what exactly this subject is talking about, that we need to understand. See, theory of computation, right? Something theory about something, correct? Theory about what? Computation. So we need to understand very clearly computation. Fine, man. Just before addressing into this term, as I told you, number of marks, average number of marks we can expect from this subject will be, so 10 marks we can say. Are you getting my point? Yes. So the major in this course, what is going to be discussed here, there are many mathematical models are there. That is nothing but computing models like finite automata or push down automata, Turing machine or linear bounded automata. These are automatas, their capabilities will observe, as well as some of the formal languages we have. This formal language generally used in parsing or even compilers like in lexical analysis phase. So there are many applications are there. So we'll be addressing into different languages, different formal languages, their representation like grammars and mathematical models will be dealing in this course. Fine. So first we will understand clearly about theory of computation. Means theory of computation nothing but theory of computation. Computation means the word is there, computation. What is the meaning of computation? We need to understand. So let me introduce myself. I am Ravi. I have completed my MTech from the Usmani University. So I'm having more than 5 years of experience in the GATE domain. Like have taught in different subjects, like in different cities of throughout India, like different coaching centers I worked. So my area of interest, like my area of subjects, are operating system and computer organization and theory of computation and compilers. So these are the subject I taught in different cities across India, like almost like many batches I taught. So for you, I'll be dealing what theory of computation. So look, all of you, what is the term computation? It says. So somebody can tell what is meaning of computation. Computing. What is computing? Something calculation, right? Computing something calculation. In our term, computation nothing but something execution, right? So okay, I can use like this. Computation. What is the meaning of computation? Computation is executing programs. That is nothing to understand. The way program computation is carried out is nothing but what? Executing program. Computing, executing program. Theory of computation means theory of computation nothing but, can I say theory of programs only? Executing program is a computation, nothing but we are studying about theory of that. So nothing but we can say theory of programs only, correct or not? So our theory just turned into what? Programs. So now we will be dealing with what? Theory of computation, nothing but theory of programs. So look this. Now our theory of computation nothing but what? Theory of program fundamentally we should talk. So what is meant by program? Somebody you can tell. Program you can define like set of instructions But instead of set of instructions, something there is something fundamental behind the program is there, correct or not? What we do in a program, step by step action will write. That is nothing but some kind of algorithm will run or not. Yes or no? There is something fundamental behind the program. Exists is nothing but algorithm. Yes or no? See, some algorithm will be there. That algorithm will be expressed in some of the programming language. That is considered a program only. See example, if I take C language, some problem is there. That problem I want to solve it, for which a set of steps, like set of step, finite number of steps will carried out. That will be expressed in one of the programming language. That is considered to be a program only. So now our theories look this. There's something fundamental behind the program is nothing but algorithm. So what algorithm? Algorithm express in programming language. So we say that programs express algorithm language. Correct? Program expressed in algorithms. Yes or no? Now just our theory is thrown into what algorithm. So now I can say theory of computation, nothing but theory of program only. Program, there must be something existed behind that. Algorithm, theory of algorithm. What is mean by algorithm? We need to understand. Hello my dear students. So now we need to look into algorithm. Yes, you might knowing it. Algorithm nothing but what? What algorithm do? Just before addressing into algorithm, let me take an example. So generally program or algorithm will use for solving some particular problem. It is kind of some method, it kind of procedure you understand. Let's take you are at kitchen, so you wanted to prepare one dish. What can be done? You must collect some raw material, yes or no? Some raw things you have to collect it. Inputs, that you can say inputs, and you have to follow some set of steps. Correct on that algorithm will give sequence of steps to follow or to process and will get the output, correct or not? Yes, suppose some kind of dish you want to prepare it, you collect all the inputs and do the step by step actions. We will get what dish will be prepared or output will get. So now algorithm is giving what? Algorithm is kind of recipe for input output transformation or not. So what is input? Collecting all raw material and getting output. So we'll be processing step by step action. So let me take a definition for algorithm. Algorithm gives us a recipe for computing. Computing you have to do process and input output transformation. Yes or no? So input output transformation nothing but what? You are taking some raw material, raw parts, all raw part. You process it, compute it, it will get what output. Yes or no? Yes or no? Yes. See, algorithm is a recipe for carrying out input and output transformation. It is steps. It is a collective method, collective steps you understand, collective actions which will carried out in our input to output transformation. Now we are going to figure out our just theories turned into what? Algorithm, theory of algorithm. So algorithm we understand. So let me take like this. All of you see. Now what algorithm will do? Look, all of you. So suppose if I take this is processing means algorithm. It is taking input. Let's take x is an input. X is an input. So now algorithm, we are giving inputs and it will produce some output like f of x, assume that. So for all inputs will get output or not? Will get output. This is algorithmic process. Yes or no? So now see, algorithm is a recipe. Is giving a recipe for computation and input output transformation. Yes or no? So now our theory little we need to convert like a function. Can I talk about function? See, what is function? It is taking some input and producing output or not? See like this. Suppose function if mapping from domain to range. Yes or no? Domain to range or not? What is domain? What is domain? Input. For input will get output or not? Yes or no? Input output transformation nothing but a function only. Function is mapping from domain to range means all inputs it is producing output or not. Yes, now our theory is just we converted, like we are carrying out in terms of what? Function. Our theory is to be study about function. So function you understand here. What is mean by function? Somebody can define what is mean by function. This you can understand here. Function, look this function is nothing but abstract notation. Yes or no? Function is nothing but what? Abstract notation. So now Now we need to understand our theory, we need to figure out in terms of function. For what are the functions we have an algorithm? For what are the functions we have algorithm? So you might confusing here, please. What I'm trying to say. So we need to understand clearly what this subject is talking about. Look, this I will concluding here. We have lot of ideas are there, that ideas we are expressing in terms of functions. The function will be realized with algorithm will be expressed in what? Programming language, nothing but you will get machine. Suppose any kind of machine, if you take computing machine, if you take designs, if you observe, there must be some logic existed, our thought process existed. Our thought process were represented in terms of what? Some function. The function, how to carry out function should be realized with some algorithm only. Let's take example, I want to compute addition, or let's take an example, I want to check given number is prime or not. That is my thought. How to express? So in terms of function can be expressed or not? Yes, I can express generating or computing what prime number. So when you know function can be realized some algorithm. We can write some algorithm. That algorithm can be realized with some of the programming language. But for what are the functions we have algorithm? Do we have algorithm for each and every function? That is a question. There are many problems in the world for which there is no algorithm to compute it. Means there is no any mathematical model, computing model to solve the problem. But our theory is to be what are the problems are there, for which what are the algorithms we have, for which we either whether able to compute it or not, that we need to go understand. Are you getting? So just I'm trying to say here. Let's take for what all the function we have algorithm. If I take function as a prime, I'm checking this. Given n is prime or not. Given n is prime or not. Given number is prime or not. How to check? How to check? So I can take a function like is prime mapping to input to output. What is input? Input is n. Suppose input is n. What is the output? You can get output yes or no. Yes or no. So take input, take a number input. Any number you take n and check it whether that is prime or not. If it is prime, yes, otherwise no. So for which I can easily we can write the function like this. So I'm taking prime n, that is equal to yes or no. That two things will be there when n is prime. When n is prime, yes, otherwise n is not prime, no. So this is my function. How to realize a function here? Please simple. You know logic for finding the prime number or not, like whether given number is prime or not. We know logic. What is the logic? Take a number, find the factors. For any number you have exactly two factors, that is a prime, otherwise not prime. Simply that logic I can write step by step actions can be right or not. That is nothing but you are express this function is expressed in algorithm or not. Please do understand what is the algorithm. See, to carry out prime number, given number is prime or not, how to check? Right, I have to write the logic. So take it and find the factor. If you have a two factors only, that is prime, otherwise no prime. This sequence of nothing steps, nothing but algorithms expressed in programming language. Yes or no? That is nothing but theory of computation, nothing but theory of program, nothing but theory of algorithm, nothing but talking about function. For what are the function we have algorithm, that we have to understand. I hope you are getting now what the subject is talking about. The subject is talking about for like just our ideas are we are representing in terms of function, for which we have computing models or not, that we need to understand here. I hope you are getting mark. So note down these things. All of you, please note down these things. So now this theory of computation majorly we are looking in terms of three aspects. Look this all of you. So theory of computation majorly looking into three aspects. One, two, three. One is theory of automatas. Please do understand theory of theory of automata. Theory of automata. Next one, theory of computability. Theory of computability. Computability. Next, theory of complexity. Theory of complexity. Please do understand all of it. So our subject is completely covering our three aspects here. What are three aspects here? One is theory of automatas, another theory of computability, third one is theory of complexity. 85 percentage of the our course will be talking about theory of automata. Are you getting my point? Remaining 10% is talking about theory of computability. Just 5% we are talking about theory of complexity. We must understand what these three aspects is talking about. Please do understand. First one, theory of automata. What is theory of automata is talking about, that we need to understand. Please look all of it. It deals with definitions and properties of automatas. So theory of automata, it is deals with definition and properties of mathematical models. There are mathematical models. So it is talking about mathematical models. Example, mathematical model example, if I take FA. Second one, I can take push down automata, or it is generating what, context free grammar. Context free grammar. Please do understand. 85 percentage of the work we are talking of theory of automata, nothing but there are computing models are there. There are many models: finite automata, push down automata, Turing machine, linear bounded automata. Their properties, their capabilities will observe here. So example, if I take finite automata as one of the mathematical model. What this purpose of finite automata? There are major applications we have. So applications are text processing. Applications are text processing. And in terms of compilers, we are using in compilers. So what is the meaning of text processing? What happening? Wherever pattern matchings are there, that is nothing but FA is working. Let's take some application. It is taking input first, for entry section we have passwords. So when you are entering password, we have to cross check this given password and whichever you stored password will be matching or not. Wherever pattern matchings occur, so that is nothing but internally FA is running. In compiler, there is a first field called analyzer. Lexical analyzer, syntax analyzer, and the semantic analyzers are there. In under lexical analyzer, so stream of tokens are accepted by FA only. This is one of the application you understand. Another applications, if we see, in hardware, digital switching circuit. Like you might knowing finite state machines are there. Like if I talk about circuit and set of states are there. In each state there are two things will be there, on and off, 0 or 1, correct or not. In that such applications also for debugging the switching circuits, we are using FAs only. Finite state machines like Moore and Williams machines are used. This is a major applications of mathematical model FA. And if I take push down automata or context free grammar, the grammars are used in programming language and artificial intelligence. Programming language, how the programming language will use? In programming language, syntax analysis is there. Syntax analysis or parsing will call. Syntax analysis or parsing. In this area, we are using context free grammar. So these are the major applications of theory of automata. Are you getting? So I may give a list here. Theory of automata, it deals with the definitions and properties of the mathematical models of computation. Example I given, finite automata and context free grammar. So you note down this thing. Applications are text processing, compilers, hardware design, that is switching circuit, and used in programming language. Theory of automata. Next one, theory of computability. I told you, correct. So theory of computability means here. So it is deals with whether the problem is solvable or not. Please do understand. I told you just now there are many problems, thousands, like lakhs of problems are there for which no solution, and we have to just decide whether the problem is solvable or not. That's all only. Second one I'm writing. theory of computability, whether the problem is solvable or not, that we need to understand. See, let's take an example. One example I'll give. One question to all of you. So determining that whether the given mathematical statement is true or false. Suppose I will give us a mathematical statement. True or false? Do we have algorithm? Do we have any algorithm to determine the given mathematical statement is true or false? Let's take 2 plus 3 equal to 5. True or false, ma? True. And 3 plus 4 equal to 6. True or false? False. Correct. My question to this for this mathematical statement, do we have any algorithm to test this is true or false? Yes, literally I'm telling, we don't have algorithm to check this one. See, I have to maintain so much domain knowledge to understand whether to say this statement is true or false, correct or not. So I'm changing different mathematical statement. Again, that information also should be captured, correct or not. Yes, this statement looking easy, but implementation part very difficult. Are you getting my point? I'm writing. The problem of determining whether a mathematical statement is true or false. No computing algorithm can perform this task. Yes, literally you should believe it. We don't have an algorithm to test this statement is true or false. It is looking easy, correct or not? You may thinking, if I give any mathematical statement, you can tell, sir, it is true or false, because you have some domain knowledge. Suppose if I give any mathematical statement, you don't have in that domain knowledge, can you able to say that that is true or false? So that capturing that information and giving to an algorithm is very difficult. Yes. So theory of computability is talking about whether the problem is solvable or not. There are many problems are there which are unsolvable problems. There are unsolvable problems of plenty. And insoluble problems also, some are easy, some are odd. So theory of computability is always talking about just given problem solvable or not. You just tell me that solvable or not. That only you have to do it. So that work we are done doing in theory of computability. And third aspect is theory of complexity. As I told you, problem can be solvable, but the solvable problem will be easy or hard. You might knowing also. Example, if I say compute addition of two numbers, whether it is easy or hard. Yes, easy, only take two numbers and do the addition. But if I ask a question like in the university there are 2000 classrooms are there, assume that 2000 classrooms are there, and different branches of different courses of students are there, and I want to schedule the examination, like I want to conduct the examination, and I want to assign the classroom for exams, and you have to schedule, like scheduling problem if I take, you have to schedule uh, the classroom for exam, means no two courses should be in a same classroom at the same day. You're getting my point? No two courses should be sit in same classroom and same time. Such a way you have to schedule it. There are 2000 classrooms are there, many courses are there, thousands of students are available, and scheduling this examination will be difficult or not. It is solvable, but it is taking how many days it will take? May takes in terms of days also, months also, correct or not? So now theory of complexity always talking about you have to decide whether problem is easy or hard. You know, like you observe also, if I take sorting problem in data structure you studied sorting, if I take bubble sort, how much time required to sort a given n numbers, order of n square? Yes or no? But when I take like a traveling salesperson problem is there, so you must study algorithm, correct or not? There are problems which is taking exponential time. There are some problems taking only polynomial time. You have to decide it that whether problem is easy or odd. That is talking about theory of complexity. Hello students, I hope you are getting. So now we understood very clearly what this subject is talking about. Just I'm concluding now. Overall theory of computation is talking about there are mathematical models are there, their capability we need to observe, and problems we have to observe like whether easy or tough problem, solvable or unsolvable problems we'll observe, and also some formal languages and their application. These are the things are we are going to cover in this subject now. So introduction part I given, and Slowly other terms I'm going to introduce, and each term you will understand. Like example, what is automata, what is grammar, what is the language, what is the formal language. So these are the terms we need to discuss first, then we'll start actual subject now. Fine.